We published an 11-page slideshare on what it takes for CCPA and GDPR. Now, here is a video showing what it takes to deliver privacy compliance and why we say 2 to 5 years no technology and 3 months to 2 years with comprehensive technology. Here, I'm starting a more simplistic data protection impact assessment component to discover for emails and IP addresses in a HADOP HDFS file system. I'm first looking at where the pattern of the file's addresses were found. In this case, files 1, 2, 3, and in column 6 for all 3 files. Next, I'm looking into a small subset of the files to verify their actual IP addresses versus false positives, and seeing the surrounding data helps make the correct decision. Now I have decided to go through a remediation procedure to protect this personal information. I have a few choices how to do so. I can encrypt the entire file by moving the file into an encrypted zone, or encrypt the column that the IP address exists in. I'm choosing to encrypt column 6, where the IP address was found, and doing so only for one file for the purpose of this demo. Now that the job has completed, we can see that in file 1, the IP address column is encrypted as expected, and file 2 and 3 are not. Now I'm establishing the connectivity, mostly reconfigured for me, to a JDBC RDBMS compliant data source. Now the application through the catalog connection lists the tables in the database for selection and processing. Now I will do a discovery for patterns matching emails, IP addresses, and social security numbers. I will not be writing any data back to the database, only to the extensive collaborative metadata catalogs for review. Here we see 2 of several Spark parameters, and we'll see many others later available to tune and speed up the process. Here the user can select the predetermined keys to the files or select their own, and control how many records are loaded into the petitions at one time. These 2 alone can speed up processes by 50 to 75%. Here we review what personal data we are discovering. Here we see quickly the data in the file we were discovering for now as we look at the result of the job in the metadata created. We see where the job discovered the patterns of the values we were looking for, and where they found and how many of each were found to the column and row levels. All part of a thorough DPA. Now I am setting up a run against another RDBMS database to find the patterns for social security numbers. And when those patterns are found for the application to encrypt those values in each column and row. Then when complete, store that information in the metadata catalog. Then write the complete file backup to the original database under a new name for the DBA to process. As we see in the original file, the social security is not encrypted. And then when we refresh, we see the new file with a new file name with the social security numbers encrypted, and another column suspected of social security numbers. We also see the other file in the database was not affected. Now for the other file in the database, I will run a citizen's right of erasure using several values, delimited. The application will search for and physically delete the values from the file it will write back to the database, and also stores this information in the metadata catalog. Here we can see in the original file that the citizen's data exits at this time, and later we'll see that it does not in the newly formed file. This is the metadata where the citizen's data was found for erasure by request. As discussed earlier, here are the parameters for Spark to allow for tuning to quicken up runtimes. These times can be as much as from 12 hours runtime to 2 minutes in total run duration, with just a little tweaking of these parameters. Now we run a live erasure for the citizen's request of erasure. We can see that her information still exists in the original file in the database. Now I will copy her email and go into the newly created file, and her information will no longer exist, as we expected. After running the right of erasure process, we verify this by doing a search in the file utility against the file and see no results are returned. Now we do the same search with her email value against the original file, and are returned with her email existing in that file, demonstrating our erasure process is working as expected. I am now showing the results of some of the biometric features of the applications. Here I was searching for a C programming book, and it was successfully found in a picture among several other pictures with the C programming book. I am now searching through the facial recognition portion of our biometrics applications. I'm looking for a picture of myself throughout a larger database of pictures, me and Elvis and others. The lower the number returned, the more likely the match of pictures. So this 0 match should return a picture of me. The pictures are attempted to be matched against a self-learning setup. Pictures in the self-learning database are to allow for the most likely correct matches of facial pictures. Here I am showing a high number or lower probability of a matching picture of me, and I sure wish I looked like Elvis, as it's a 60 match. Here I'm showing an example of how the application reads an outlook.pst email file. It first reads the actual email, scans and discovers for values and patterns like any other file from our library of patterns and values. It also shows highlighted any of the values it finds. It shows all the attachments and also scans the attachments for the same discovery requests. It also allows for the opening and downloading of the emails as well as the attachments. The discovery engine is one of the core components to the application. This establishes the shareable collaborative BigDataRevealed base library of pattern recognition and value discovery for DPIA locations for right of erasure encryption, and many more important components of this comprehensive GDPR and CCPA Big Data Accelerator technology. This is where the DBA sets the base parameters for the database for ease of use later for others. The metadata export allows for the export of all these separate catalogs and the selection of dates and patterns and values to be downloaded. The standard form of download is Excel, though the data is stored in a database. Also, you will find most all transactions stored in the application's metadata. The transactions are stored at the file column row levels. The application sets up watches so that when outlier discoveries exceed a level or incoming IoT values exceed a threshold, a nominated person is sent an SMS, text, or email notification immediately. As a user enters their personal data, it's then encrypted and generates a new identity encryption key for future access to communicate with companies. Their rights under the GDPR are the soon CCPA and other regulatory agencies. This section allows the citizen to upload or download documents and share bilateral text communications with the company. It also allows them to select the company they want to make requests to, one at a time or a whole group. Now the company is logged in and is searching for new citizen requests. It has found one from Jennifer. As we saw earlier, Jennifer had some of her data encrypted. This will obviously make it difficult to search for her data against non-encrypted data. The company drags over the pattern discovery icon and will prepare for the discovery run to find Jennifer's location of her data. The company selects the Jennifer request to begin the submission of the search for Jennifer's personal data. As we can see, the application auto-populates Jennifer's personal data to be searched for again. This is non-encrypted data, and even if it were, it would have to use the same file master's key to get a match. Those keys are hidden off the grid. Now the company is selecting to run the data discovery to collect the metadata catalog so the user can drill into the result of Jennifer's or other pattern discovery jobs. This metadata can be exported and used in legacy or in other areas that need the metadata catalog path and location within the file information. Now the user can mouse over the pie charts images to view what values were found and how many of each. Even the values that were encrypted were found and counted for. This is done automatically by the application in the background process with algorithms and knowledge of file encryption key, and ability to convert the file data on the fly to find matches accurately and completely that are made by the citizen. Without this ability, the company would be in violation of CCPA and GDPR. Now the user is viewing Jennifer's data to show there's encrypted fields she requested that normally would not be found. This is a major feature for properly following regulatory requests such as right of erasure. Here we can see in the executive summary and data scientist, data steward, and management toolkit interface. We found values for the citizen, both that are not encrypted and the others that are encrypted. We now allow the drilling capability with the guidance of the metadata catalogs to see the files. Other records and rows all the way down to the actual system source of record. In this case, stored in an Apache 3.1 HDFS. This is helpful to verify you have the right record for the right person and not a false positive, and can also use the surrounding data for verification. Here we are looking at an encrypted value of the requester. We are now drilling to see the files, other records and rows, all the way down to the actual system source of record for this other value. Again, this is helpful to verify you have the right record for the right person and not a false positive, and can also use surrounding data for verification. Now the users can mouse over the pie chart in Gauge to view what values were found and how many of each. Even the values that were encrypted were found and accounted for. We can see within the Excel spreadsheet the file number of rows and values that were found in our searches. This helps to identify the exact values we need to search for to deliver in the citizen's regulatory rights of their request. It also will show the same information of patterns searched for, such as phone numbers, emails, social security numbers, and unlimited others. This information becomes invaluable to use your existing metadata in ETL tools for remediation at the legacy database levels. This metadata also becomes invaluable as proof of your actions, remediations, and should also be used after you run your data protection impact assessments. I want to show you some of the application's new gauges, graphs, charts, and drill capabilities. All of this is in Wildfly 10 D3.js and AngularJS open source. Welcome to BigDataRevealed on the Amazon AWS S3 cloud. This release sources S3 and Apache HADOP. Here you'll see files on the AWS S3 and the HADOP in the folder file tree. This is where you select what data assets you want to discover for meeting the EU GDPR and other government regulatory requirements. BigDataRevealed offers two ways to view results: the technician's dashboard and the executive summary with graphs and drill. First, let's view some discovery results from the quick classification. Let's first inquire on why we have Social Security in only 2.9% of this column's data assets. This column looks like IP addresses with some Social Security numbers, most likely mistakenly left over or put in there by error. After searching the column's data assets for the pattern of Social Security, we see only a small amount of Social Security numbers found in as we drill into one. We see the surrounding data in the file. Now we take the path of the pattern run for Social Security and look at column 11 to verify it is not a false positive. After viewing the column's values and then drilling into one of the Social Security records, we see it is not a false positive. Now that we verified it as a Social Security, we make the decision to protect this data. We select the sequester button, select the checkbox so all the history and existing files are deleted, and select the column we wish to encrypt and select the Run button. The encryption process is started by clicking the Open Decryption button it shows in column 11 is encrypted. To verify this, we look with the File Content Viewer and see the Social Security data assets have been encrypted with the technician's dashboard. We select and view the result of data discovered, run to view, and verify further all the Social Security data assets were encrypted. We can also see other data asset statistics from the discovery run. We also drill into one of the data assets to verify that down to the system source of record. In this case, in an S3 bucket column, it is encrypted as expected. Now let's look at what we feel companies will struggle with the most in becoming GDPR compliant. Remember these words: indirect identifiers. In this process, we first select one or multiple keys direct identifiers to find which files can be joined to the other files by one or more of these keys. In this example, I choose just the email key identifier. This will find the correlations across all the selected files and store the files in percentage of the matches found. This is then used in the second phase, where BigDataRevealed then takes each one of the unique assets value in all of their permutations across all the joint files, looking for the user's selected indirect identifiers. These values can be gender, postal codes, dates, and other values that when combined can within a reasonable percentage identify a person or small group of people, and will list the individual's data assets in the files in columns and rows. They were found, and if found and not remediated, this is a GDPR violation. This same process is used to find and remediate citizens' rights of erasures, or otherwise known as right to be forgotten, and to also take away consent for certain requested, personally identifiable information while allowing others to be used, such as email to receive discounts. Now for a specific email, we click the checkbox of the IP address, value, and click the encrypt button. This will encrypt the data assets values shown by the file, column, row, and pattern type. Now that the encryption job has complete, we can view the results in the file content reader and see that the IP address for that citizen's email was selected and has been encrypted. If this was done in error or the citizen changed their consent, the value or values can be easily decrypted. Here we can see the decryption took place, and here we can see there are no encrypted values. Now let's look at the process to run IoT streaming data jobs. First, we create what's called the producer file that identifies the stream data, credentials, and other information needed. As we look at a completed stream's results, we see what pattern discovery the user chose can be one or many whatever pattern discoveries the user selected. When the stream data is found to match one or more of the patterns, that data asset value will be encrypted on the fly and written to the file storing this data safely and encrypted. This encryption can be decrypted if an error, and a user can also, after reviewing the stored streams, they can select columns out of the data to be decrypted as well as, and can select new columns to be encrypted or not. In data discovery, we have basic data profiling results, as well as outlier discovery with notifications to capture when parts may be wearing out or banking activities that may detect money laundering. The control panel allows for server settings, security settings, user permissions, and much more. BigDataRevealed offers log files for security and traceability of jobs and processes run. First example, as we see the customer file has no encryption values in the first and last name, as well as the email and credit card numbers are not encrypted. Now we will enter in these values that will invoke the BigDataRevealed application interface and match. The company entered user data and brought back this data and made it available for the company's operational systems or analytical systems. Normal processing. Now we will apply GDP or compliance remediation encryption to the email and credit card columns so we can show that the BigDataRevealed application program interface will still find the customer based on unencrypted data keyed in by the point of sale person or passed on by the analytics or research system. We can now see that the email and credit card column values are encrypted and should be to keep your customer and citizens' personal data safe from hackers and internal data theft. Now we will enter in plain English once again these values, though the email and the credit card are now stored encrypted and will invoke the BigDataRevealed application interface and still match. The company entered user data and bring back the correct customer data and make it available for the company's operational systems or analytical systems normal processing. The BigDataRevealed application program interface was able to find users' entered values even if and when the users entered them in any of the integral interface values created by the company by both the unencrypted and or encrypted values. In return, the correct customer record to continue the processing. Just to clarify, even though we returned into memory for you to continue your processing with unencrypted data only for the requested customers or customer, we do not encrypt the system source of record. So your originating record stays safe and compliant. In closing, we hope you take GDPR and CCPA and all regulatory requirements serious, for the risks and outcomes can be horrific on companies and their customers. We also hope you believe in our expertise and time and effort in building what we feel is the industry's only complete, comprehensive GDPR and CCPA full compliance solution, and that our belief that without comprehensive solutions like BigDataRevealed plan on many years till compliancy, and most likely with any errors or use BigDataRevealed and cut delivery times down by years, and in many cases down to just months, running 24/7, 365. Our main components and ecosystems are around the most accepted technologies in the world: Spark 243, Java, Apache 3, AngularJS, D3.js, Wildfly 10, Kafka 2.1, JDBC, and more. Call Steve directly for any questions, demos, trial periods, proof of concept, white labeling, even small angel funding. Reach me at 847-791-7838 or email at steven@gdprcompliancymaster.com. Thank you kindly for watching this video.